Hey guys, it's Miss Terizzi here, getting ready to record the lesson for the second week, which is compound probability. But let me point some things out based on what I was seeing last week. Guys, I think it's really important that you really read and pay attention to the directions that I am posting in your Google Classroom. A lot of kids were doing the wrong IXL assignments, having problems figuring out what to do on Khan. You really need to read the directions and make sure that when you're doing a Khan assignment, you watch the video all the way to the end and then hit next assignment so you can get credit for it. We were having some problems with that last week also. If you want help, I'm available on Zoom every day from 10 to 12. Your parents have the code for that, and if you can't find it, please let me know. All right, perfect. Last week we just did simple single event probability. This week we are going to do compound probability of independent events. Okay, independent events. Independent events, I'm going to write this down. One event does not affect the other. For example, if, like in your notes, you've got a spinner and a dice. If you spin that spinner and then you roll that dice, what you get on the spinner will not affect what you get on the dice. So, another example, okay, would be a coin, flipping a coin and rolling a dice. Okay, flipping a coin and rolling a dice. The description is this: one event does not affect the other. Now, the notes say this: the probability of A and B, you do the probability of A times the probability of B. So, this is taking what we did last week a step further, and you are going to always multiply the probabilities that they are asking about. Always, always multiply. Please use your calculators. Always, always multiply. All right, so the first example that I'm going to look at here, we've got, it says example 1. We have letter tiles. They are G, B, E, and A. And then we have a spinner that is split into 3 sections, and it's A, B, C. Now, we're going to draw a tree diagram for this. I'm going to explain it with a tree diagram because it makes you understand where it comes from, and then we're going to look at it just using compound probability. So, what this problem is you are going to pick a letter from the number tiles, and then you're going to spin the spinner. So this is what a tree diagram looks like. When I pick a letter from these tiles, I will either get a G, a B, an E, or an A. So I reach my hand in a bag, I'm going to get one of those letters. Now, once I pick a G, I'm going to spin my spinner, and I could get an A, a B, or a C. Okay, I'm going to pick a tile, and then I'm going to spin a spinner. So, again, if I pick a B from the tile, I could spin the spinner and get an A, B, or a C. If I pick an E, I could spin my spinner and get an A, B, or a C. If I pick an A from the tiles, I could spin my spinner and get an A, B, or a C. So, I'm going to go over here, and I'm going to write down all of our outcomes. The first, I could pick a G and then get an A. The second, I could pick a G and then get a B. I could pick a G and then get a C. I could now pick a B from the tile and spin an A, so BA. I could pick a B and spin a B. I could pick a B and spin a C. Next one, I could pick an E and spin an A, an E and a B, an E and a C, and last but not least, an A and an A, an A and a B, an A and a C. So, if we pick a tile, and then spin a spinner, these are all of our outcomes. Every single outcome. That's all we could get if we did this experiment. And it says, what is the probability that you get 2 vowels? Well, remember, vowels are A, E, I, O, and U. So let's look down this list. 2 vowels. Here's 2 vowels, an E and an A. And here's 2 vowels, an A and an A. So the probability that they are both vowels is 2 out of 9. Now, that is one way to do a problem like this. Not a very effective way. I would never want to do that. So let me show you just using straight up multiplication. So we're saying, what's the probability that they're both going to be vowels? So we're going to do the probability of a vowel out of this stack times the probability of a vowel on the spinner. So let's look at just this. Probability of getting a vowel out of this group, this is simple probability like we did last week, is 2 out of 4 times, you always multiply. What's the probability of getting a vowel here? 1 out of 3. And if you multiply this, you will end up with, you multiply straight across. Oh, you know what? I'm a knucklehead. There's not 9 possibilities here. There's 12. 12. 2 12s, which is 1/6. When I multiply this, I get 2 over 12, which reduces to 1/6. Now, which one of these was easier? Obviously, the second method, where you don't have to make a tree diagram, because that would be very tedious and long if you had to do that for every problem. So, the key here, compound probabilities, and these are independent events. One does not affect the other. Next week, we're going to do dependent. We're not worrying about that now. Independent, one does not affect the other. All you do is multiply the probabilities. All right, let's go back to the notes. It says, what is the probability on that spinner of not getting blue? This is example 2. Probability of not getting blue, and then rolling a 3 or a 4 on the dice. So times the probability of a 3 or a 4. Okay, so if we look at this spinner, 1 section is blue out of 5 sections. So 4 are not blue. So 4 out of 5 are not blue, times 3 or 4 on a dice, that's 2 out of 6. When you multiply this, please use your calculators, you will get 4/15. If you do reducing, 2 goes into 2 once, into 6 3 times, multiply straight across. Please just use your calculators. Okay, example 3. A number cube is rolled and then a coin is tossed. What is the probability of the cube landing on a 5 or a 6 and the coin landing on 10? So, probability of 5 or 6 times probability of heads. Okay, I think I said landing on 10. I meant landing on heads. So, 5 or 6 is 3 out of, or no, why am I saying 3? It is 2 out of 6 possibilities times, on a coin, one side is heads out of 2 possibilities. First of all, those are both theoretical probability. Last week we talked about experimental and theoretical. This is just theoretical based on the results. And the dice and the coin do not affect each other, so they are independent. If I simplify this, I will end up getting 1/6. You can use your calculators. Do not even worry about trying to simplify them. All right. Example 4. It says, there are 4 oranges, 7 pears, and 5 apples in a fruit basket. Iggy selects a piece of fruit at random and then returns it to the basket. First of all, I wouldn't do that, but whatever. We're just doing a math problem. And then Terrence selects a piece of fruit at random. Find the probability that 2 apples are chosen. So we want to find the probability that Iggy gets an apple. He puts it back, and then Terrence picks an apple, okay? So the probability that the first guy gets an apple, well, there are 5 apples out of 16 total pieces of fruit if you add them up. 4 plus 7 plus 5 is 16. Times, Iggy takes the apple, looks at it, puts it back in the basket. So what's the probability that the second guy gets an apple? Is still 5 out of 16. When you multiply that, you get 25 over 256. All right, let me erase this. We'll look at a couple more examples. That example, the one with the 2 pieces of fruit, I'm not in love with that because why would you pick a piece and put it back? But we're just going with the examples for the week. That is independent. One does not affect the other. We will come back to a problem like that, similar to that next week. Okay. Example 5 says this. Spinners P and Q are shown below, are divided into congruent sections. The arrow on each spinner will be spun once. The number in the section where the arrow lands on spinner P will be added to the number that it lands on Q. So 1, 2, 3, this is spinner P, and then 1, 2, 3, that is spinner Q. So you understand what's going to happen. We're going to spin this one, and then add it to what we get when we spin that one. It says, what is the probability that the sum of the numbers will be 5? Now, this is one where you have to find the outcomes. So, we're going to draw a tree diagram. Spinner P, I could get 1, 2, or 3. Now, spinner Q, I could get 1, 2, 3, 1, 2, 3, 1, 2, 3. So you understand what this is. These are the possible outcomes on spinner P. I can roll a 1 or spin a 1. And then when I get a 1 there, I go and spin this one and I could get a 1, 2, or 3. Same thing here. I can get a 2. I'd spin this one and get a 1, 2, or 3. Now, they want us to find the sum. So, sum means add. 1 plus 1 is 2. 1 plus 2 is 3. 1 plus 3 is 4. 2 plus 1 is 3. 2 plus 2 is 4. 2 plus 3 is 5. 3 plus 1 is 4. 3 plus 2 is 5. 3 plus 3 is 6. So here's all my outcomes, and there are 9 of them. We want to know the probability that the sum will be a 5. Well, we've got 2 5s out of 9 outcomes. Probability is 2 out of 9. You have to do that one by making a tree diagram. Okay, last example. Example 6. It says, you toss 3 quarters at the same time. What is the probability that all quarters will land on heads? Well, we're going to have probability of heads times, we always multiply. Probability of heads, and there are 3 of them, times probability of heads. Well, the probability of getting heads on a coin is 1 out of 2, times 1 out of 2, times 1 out of 2, multiply straight across, 1/8. So the probability that they will all land on on heads is 1/8. Now, quick review. You could write this as a decimal, 0.0125, or a percent, 12.5%. Remember, you move it 2 places to the right. All right. Hopefully that helped. If it didn't, come to the Zoom sessions and I will be happy to help you. Have a great week, guys.